Hello, very good morning to all of you. How are you? I hope you all are happy and healthy and fine at home. So, what did we discuss yesterday? Yesterday we discussed the synthesis of nucleotide as well as nucleosides. What do you mean by nucleoside? What do you mean by the nucleotide? And what they are forming, that type of the thing we have discussed yesterday. What we are going to discuss today? So today we are going to discuss about the synthesis of adenosine. Synthesis of adenosine, and as we know that we are starting, what is the starting material used for synthesis of that? We are going to use, first one is a ribose, that is, as we know that ribose is having CHO, then COH, H I am writing this one COH, then H, then COH, then CH2OH. 1, 2, 3, 4 and 5 carbon atom present over there. This is the structure of D minus. D stand for, it is a relative configuration, and when when OH group is on the right hand side at a chiral center is known as D configuration. And as we know that OH chiral center means what? The carbon atom attached to 4 different group is known as a chiral carbon, and that chiral carbon over there. And now when this compound is a D minus ribose sugar, D minus ribose, it is a sugar unit, right? This is a sugar unit. Now this one further treated with the protecting group, which we already learned that. Let us see here, PH3CCl, that is a triphenyl methane chloride, or it is called as a trityl chloride, right? And this trityl chloride, the speciality of this trityl chloride, it selectively protect the primary alcohol only, do not protect the secondary. Look at here the number of OH group present in this compound, in this ribose, 1, 2, 3 and 4. Among these 1, 2, 3 are the secondary alcohol and only one is a primary alcohol. And the speciality of this trityl chloride, it is selectively protecting this primary group, this primary alcohol, so that you are going to get, what you are going to get here, alcohol, this aldehyde group C, OH, then H, then C, OH, H, C, OH, H, they remains as it is, then O, then what is that, this CPH3, that is the group get attached to that, means the this is a protection of primary alcohol, right? So now when this compound, let us see this compound normally is present, or it is in the form of at an equilibrium, it may exist in the form like this. So it open chain as well as it is present in the cyclic form. How it is, cyclic form is shown here. So O, then here remember this one, then here O, in short we are writing this one is a trityl one, and then there are OH group here, OH, and all OH are below the plane, because all OH all are on the same side in the D minus. Minus indicate as a Leo rotatory, and that minus, or sometime it is written as a small l, they are the experimental quantities, and D and capital D and capital L are the relative configuration. So don't mix these two terms each other, that capital D and capital L are the relative configuration, whereas minus or plus, they are the experimental quantities. They don't have a relation with them. So let us see over here, when this structure, this further treated with Ac2O. Ac2O is nothing but acetic anhydride. This Ac2O, generally we are writing like this: acetic anhydride, C double bond OO, C double bond OO, and this group we know that it is a AC, and here also as a AC twice and O, and therefore it is known as a acetic anhydride, right? And what does acetic anhydride do here? It will protect the secondary alcohol or primary, whatever it may be, they get acylated, and further you are going to get the structure over here, this one, the OAC, then OAC, then OAC, and this group is already protected with the trityl group. And now when this one is treated with the reagent like H2, hydrogenously H2, in presence of palladium and the charcoal, what will happen? It will selectively these hydrogenolysis, H2 in presence of palladium charcoal, it is selectively remove this group only. These get free OH, so that we are going to get the product over here, this one. So here OH get free, and this protected acetyl group, it does not get cleaved, it remains as it is here. So that is the what we can call it as a selectivity of that protection. And after that, what you are going to do here, further this group further treated with this one, further treated with, there are the various reagent I am going to put here. First one I am going to add acetic anhydride. While adding as acetic anhydride, what you are going to get? This group get acylated. Then second one I am using, that is a dry HCl, hydrogen chloride, that then attack from opposite side of leaving group, then attaches from this one, attaches from opposite side of leaving group, opposite side of leaving group. I am in short writing as a LG, means that leaving group. So what you are going to get over here, this group get acylated further, and you are going to get only, it will deprotect this one, and chlorine group get selectively get substituted over there, and you are going to get, here is a Cl, then this one OAC remains as it is, here OAC remains as it is, and the OAC, that acetyl group, remains as it is, and this one is known as the beta chloro. This one is known as a beta chloro. Beta means that Cl is above the plane, and that's why it is called as a beta chloro. If it is below, that is called as the alpha position, beta chloro. Then 2, 3, 5 triacetyl, 2,3,5 triacetyl ribose. This is a ribose, that is a half part of the sugar, this one. So this we can call it as a part. This is the half part we got over here. Now we are going to do the next point, is a synthesis of adenine from uric acid. Next one is a synthesis of adenine from uric acid. Second one is a synthesis of adenine from uric acid. Synthesis of adenine from uric acid. Let us see the structure of uric acid will be this one, N, they are present at 1,3 position. Then here is a NH2, and then here HO, then this N, then N, not N is must be at 1,3 position, then OH present over there, hydrogen atom here, this double bond must be there. This is a structure of uric acid. This is a structure of uric acid, and this further treated with POCl3, oxyphosphoryl chloride or oxyphosphoryl chloride. When it is treated, both the OH group get replaced by chlorine atom. So what do you get over here? You are going to get the structure like this. Only the changes are occur. Other part of the organic molecules, there remains as it is. Only the OH group get replaced by the chlorine atom. That the changes. Here OH, both the OH get replaced by chlorine atom, and the resulting product we are getting this one. Now when this is further treated with ammonia, as we know that is one equivalent carefully. Here is a one equivalent carefully, and after adding ammonia one equivalent carefully, what do you get? You are going to get the, here is a not NH2, here also has a OH there, here also has a OH, and all this NH2 get replaced by chlorine atom, and specifically NH2 one equivalent carefully adding. After adding that, we are going to get this chlorine atom get replaced by this one. Let us see here, N, then what is that? Double bond here, Cl, as it is N, then N, this one H, double bond, and here we are going to get NH2, and this Cl remains as it is. So that is the changes we are getting over here. Chlorine atom and this chlorine, they are remains intact. Only this chlorine atom get replaced by amino group, and we are getting this is one of the base here, right? So in this way we can get as a base over there. Now let us see another one. Suppose we have this group, like just now we have seen OAC, then here OAC. Now at this position O, then acetyl group I am writing specifically like this, and then here is a chlorine atom, right? How the here NGP means what? Neighboring group participation takes place over here, and how the reaction takes place. Let us see here, lone pair which is present on it is going to attack on over there, and Cl is a departure. We are going to get here the product, this one here OAC, then OAC. Now here look at O, then this O, double bond C, this CS3. Now look at here, this oxygen has a 3 bond Therefore, positive charge comes on that oxygen atom. When the positive charge comes on any electronegative species carries the positive charge, that species becomes highly unstable in nature, and therefore what is going to happen here? Base. This base can be attack over there here like this. Base is going to attack over there, and this bond going to cleaved or neutralizing that positive charge, and you are going to get the product, this one, this, then this one. Here the base is coming over there, then O, C double bond O, CS3 back, then OAC, then this one OAC, they are remains as it is. In this way we can introduce the base in the sugar unit, and in this way, or we can, this structure we can draw here. This structure is nothing but we can draw the structure of this. Just now we have seen this base over here. This is a structure, OAC, then OAC, then OAC you can write, and then base will be base here N, then the base will be this one N, 5-membered ring base it is. We can write OAC N, then N, this one, here is a N, like this we can attach. So here Cl, and here I think this side double bond, here is a double bond and double bond over there. So chlorine atom, we can show one more chlorine atom between this one, here is a Cl, right? So in this way we can draw this one. Now further, this compound, this one, this compound further treated with hydrolysis. One is a hydrolysis, second one with the H2 in presence of H2, palladium in presence of barium sulfate, that is the second reagent used over there. What you are going to get, there is a removal of that oxygen atom, and you are going to get here, let us see here the structure N, then N, then N. Here is a sugar unit I am trying to draw over here, OAC, OH, this OH over there, and in this there is a NH2, then double bond, and there is a double bond, single bond, double bond, alternative double bonds over there. So that is the structure of nucleoside adenosine. This is a structure of nucleoside this is a structure of nucleoside adenosine. This is a structure of nucleoside adenosine, and this structure further treated with first one acetone in presence of acetone in presence of Ph plus, and second one Cl, P double bond O, then OCH2PH, OCH2PH. That is a second reagent added over there, and we are going to get nucleoside of adenosine. And after doing this, what you are going to get? You are going to get here 2 moles of this one PH CS3 toluene as well as S3PO4. That is the product you are going to get, and this further treated with, and we are going to H P double bond O, then this one OCH2PH, then another one OCH2PH. This is the unit you are going to get over there, and after that this one further treated with Cl2 chlorination. What do you get? This hydrogen easily get replaced by chlorine, P double bond O, then OCH2PH, another one CH2PH. That is a product you are going to get. This is a highly reactive species. This is a highly reactive, and therefore finally what you are going to get over here. So this is nothing but this one N, then N. Look at over here, this is a NH2 5-membered ring. Always remember the nitrogen in both the ring, 5-membered ring as well as 6-membered ring, they are present at 1,3 position, and then this the double bond over there, here double bond, and this joint to the sugar unit is like this, and there will be this one acetone. Further 1,2 diol protection we already seen over there, and here you are going to get CH2, then PH, and then P double bond O, then CH2PH, another one, I think not this one, OCH2PH, here OCH2PH, and second one CH2PH. This is a product we are going to get, and after getting this type of the compound, what we are going to do next, this one further treated with this one, first one with dilute H2SO4, and the second one AgNO3. Second one is a AgNO3, silver nitrate, and finally we are going to get AMP, means adenosine monophosphate. We are going to get here AMP, means adenosine monophosphate, this one. And what will be the structure of that? Let us see over here. After that we are going to get this one structure, N, then N. Let us see here, NH2, then 5-membered ring, H over here, then not OH, this is joined to the sugar unit, OH get free over here, and this one O, P double bond O, OH, and OH phosphate unit, and this double bond over there, this double bond, and this double bond over there. This is nothing but as a AMP. AMP means what? That is a adenosine monophosphate, phosphate, monophosphate. So in this way we have seen how it is synthesized. The next one is the synthesis of ADP and ATP. This is for your homework. I think with this we have completed all the part according to as a syllabus of Savitribai Phule Pune University Pune introduced at this year. We completed all this protection and the deprotection. I think in the next lecture we may going to start the remaining part of this section, that is a chiron approach, or we may start as a carbohydrate. So depending upon the situation which but here the 12 lectures are required to complete this protection and deprotection. University allotted only as a 12 lectures, so I have completed all this point. I covered all these points over here. So I think with this let us stop today here. Remaining we will see in the next lecture. Have a let us wrap up the protection and deprotection over here. Have a nice day. Thank you.